Now we're going to tackle the problem of recognizing a three-dimensional object from its visual appearance in two-dimensional images. This paradigm is referred to as appearance matching. So what we want to do is to represent and recognize three-dimensional objects using their visual appearances in two-dimensional images. So the first thing that we're going to talk about are the two basic approaches to representing a three-dimensional object. The first is based on its shape. This is the explicit representation of the three-dimensional geometry of the object. We'll talk about the pros and cons of doing that. And then we'll argue that perhaps a more attractive way to solve object recognition problems in computer vision is by just representing the appearance of the object. Now, one of the challenges with the appearance is that there isn't a single appearance of an object. It's a three-dimensional object projected onto a two-dimensional image. So you have many different appearances based on the pose of the object and perhaps other parameters, external parameters such as the illumination of the object. So what we talk about first is the learning of the appearance of an object. Given an object, how does a computer vision system learn the appearance of the object? Well, this is, common sense tells us, simply the approach of taking many different images of the object under different settings, different poses, different illumination conditions. Whatever the task may be, typically speaking, you end up with a large set of images of the object, which we will refer to as the object image set. And one of the key challenges with the object image set is that it is, generally speaking, enormous in size. Each image is fairly large, and you have many images even for a single object. So a key challenge with appearance matching is taking this data that resides in high-dimensional space and somehow compressing it down, compactly representing it in a much lower dimensional space. That approach is referred to as dimensionality reduction. And the technique we use for dimensionality reduction is called principal component analysis, PCA. PCA is very widely used in many different disciplines of science and engineering. We'll talk about what a principal component is and how we can compute the principal components given any data set. So once we have our PCA representation, our principal components, what we have is a lower dimensional linear subspace in which we can represent the original image set by simply projecting the image set. What we end up with is, for each object, a compact parametric representation of the appearance of the object. This is called the parametric appearance representation. So now we have represented the visual appearance of each one of the objects of interest to us, and we can develop a pipeline for appearance matching. So finally, we're going to talk about some example applications. These include face recognition, just general 3D object recognition, as well as applications in domains such as robotics, such as visual servoing and tracking and visual inspection.